Hi, my name is Calum David and welcome to my short implementation explanation video. Firstly, I will be going over the initialization of SDL. All this is present within the main.cpp file. Firstly, we have an int main function which has methods inside of int SDL status. SDL allows us to choose which SDL components are going to be initialized, and because of this we are using SDL init everything as we want to initialize everything. If the SDL status is not equal to OK and has initialized everything we want, a printf will then be stated in the terminal with an error claiming that the SDL initialization failed. This is just a short test to ensure that everything has been initialized upon opening the window. We then have game class equals new game, game pointer to init, and game pointer to run game loop. Once we have completed this initialization, we need to ensure to clean up all resources by shutting down the SDL. We do this by using SDL_quit. Next, we are going over the game loop and all the elements that are within it. However, firstly, I want to go over the run game loop void function. Firstly, in this function, we go over all the timing variables, such as current time index, time delta in seconds, and previous time index. Once we've done that, we then initialize the previous time index using SDL getTicks. Once we've done that, we jump into the game loop using while not quit, so while the game is open, we calculate the time elapsed, and then we use SDL getTicks again, but with current time index. We use the time delta is equal to current time index minus the previous time index. This is in milliseconds. Then the time delta in seconds equals time delta divided by 0.001f. Once we have done all this, we then store the current time index into previous time index for the next frame. We then process the inputs, update the game object, and use SDL delay to wait for a specific number of milliseconds before returning. Next, we are going over the methods of how to control the player movement. Firstly, we look at the void player process inputs function, where inside this input functions, there are vertical and horizontal inputs, which are floats, which will be used for the keys within the if functions later on. First, however, we need to ensure that the state equals idle. This means if no keys are pressed, the player will stand still. Otherwise, we'll have the player moving around constantly no matter what keys are pressed. We go straight into the input while the key is pressed using if function of the corresponding key state to be pressed. We'll have the corresponding movement direction. I have added an optional version to use the arrows or WASD keys. First, we have the vertical input of -1.0. We have vertical and horizontal inputs to ensure we can go up and down, as well as left and right. Here in the if function, we have the option of scan code up or SDL scan code W. These are the two options to go vertically up. Next, we have vertical input but 1.0 rather than -1.0 for the down direction, which has the option of scan code down or scan code S. Likewise, we have the horizontal input for right as well as scan code D. These key states allow the user direction to go right, and then the corresponding input of scan code left and scan code A to move the player left. Once we've done all this, we then calculate the player velocity using velocity pointer set X, velocity pointer set Y, velocity pointer normalize, and velocity scale to hold the speed. And lastly, to fire the bullets, we use an if key states SDL scan code space with just the state of fire. This will be discussed later on. Next, I want to go over the collision detection for the entire game. Firstly, I want to go over within game.cpp is the main void game collision detection function. Within this function, there is a for loop to check for collision between all enemies. It starts off with the for int I equals 0, I smaller than enemy size, I++. Inside this is a for vector bullet iterator it equals bullets.begin, it not equal to bullets.end. Inside that is if enemies get AABB not equals null pointer. And inside that again, if, this is the main one, if it pointer gets AAB, pointer intersects with enemies, pointer get AAB, and enemies state not equal to enemies dead, then enemies take damage, it get damage. What this means is when the bullets intersect with the enemy sprite, If the enemy state is not dead, meaning it's already been killed, if it is not dead, then the enemy needs to take damage. If it is considered dead, if the state of the enemy, which is here, is considered dead, then the NPC is already been killed, meaning it does not take damage. Then once the arrow or bullet, in this case bullet, hits the sprite, it then gets deleted. Delete it equals null pointer, it equals bullet erase it. What this does is when it hits the sprite, if it takes damage, it is then destroyed. Next, the collision detection for the NPCs when they touch the enemy. This is very similar to what is up here, same concept. However, if the enemies intersect with the player then takes damage of 10, and the player collision timer is 0. Here we use the same concept, but swapping them between. Next, I want to go over the methods of spawning for the player and for multiple NPCs. First, for setting up the player, we have player equals new player, and then player pointer init game renderer, and then player pointer set game this. This makes the player set up for the game renderer, as well as for the set game, and creating a new player. Then, for the setup of multiple NPCs, I use a for function with int I equals 0, and I is if smaller than enemy size, which is 40, then I++. Then, enemy I equals new NPC, enemy I pointer init game renderer, same concept for the player setup but for enemies, but at the end, respawn window underscore height, window underscore width. What that does is if the amount of the enemy size is lower than 40, then another NPC is created. Here is the animation aspect of the NPC. Here you can see a string path to the selected sprite, then a vector2 positioning method, and then the setup for the animation structure has animation left pointer init, then with the corresponding width and height, same for the animation right, and the animation up, down, idle, and dead. This ensures that all the different sprites within the sprite sheet string path is corresponding to the correct animation, which will then correspond to the direction at which that NPC is moving. Next is the methods of tracking points. Firstly, within npc.cpp, I have a void npc take damage function, that within this function I have used an if method to show that game pointer get player, pointer add score gets points, game pointer show score. What this means is the game will get the player, add a score and get the points, and then show that score. So they are calling each of these functions if the player health is more than 0. And when the bullet intersects with an enemy NPC, the health goes down. Hence, once their damage has been dealt, all these functions will be run. Once these have been run, within the player.cpp, the add score function will be used, which adds to the points. This pointer points plus equals points. And then the get score returns the points, which then in game.cpp will printf a player score with player pointer get points. So every single time it is added points to when damage has been dealt, it is then brought to the corresponding get score, which can be printed and shown to the user using show score function. Lastly, I want to go over just one of the methods of rendering throughout the entire game. This method is a void game draw function within game.cpp. This is one of the areas where rendering will be taking place in the game. And first, to clear the screen, we use an STL renderer clear, game renderer. Then, to draw the screen, we use an STL render copy, and this copies the game renderer, background texture, and then a player pointer draw game renderer. This draws the player and renders it onto the screen. We then have a for method of int I equals 0. I is smaller than enemy size, I++, meaning if it's smaller than enemy size, it adds another NPC, and then it draws the NPC with the game renderer. This is the exact same for the bullets, as when you need more bullets, it will then render it correspondingly. And then to present the current frame to the screen, we use an STL render present, which does the whole game renderer of the current frame on screen. Lastly, I would like to show you a game demo of my game. Here you can see you move around using either WASD or the arrow keys. You can press space to fire at any point. You can press shift to have quick bursts of speed, and as you can see, the points come up on the side of the terminal. Now, if I move out of the way of all these NPC enemies and try to survive, I've taken damage, as you can see on the terminal. If I take 50 damage in total, I will die. So I'm trying to move away and take some of them out. Depending on my direction I shoot, that's when I will be doing damage, but if I die, the game ends. The same is for if you complete the game by getting 2,000 points. Thank you for listening.